Hey everyone, in all of our previous sessions in this playlist, we have discussed about supervised learning algorithms. In this session, we will understand how unsupervised learning algorithm works. Today, we will explore K-means clustering algorithm. K-means is one of the simplest unsupervised algorithm to solve clustering problem in machine learning. It takes unlabeled data as its input because it is nothing but an unsupervised learning algorithm. K of K-means refers to the number of clusters. In K-means, our target is to predict cluster based on some feature data. We will see how K-means algorithm works internally in this session. Before we jump to the K-means algorithm, let's understand the most important keyword of K-means algorithm called centroids. Centroids are central point of each cluster. It represents the mean value of all data points of a specific cluster. If you see the picture number F, the cross point is nothing but the centroid of this cluster, and this blue cross is the centroid of this blue cluster. Let's now understand how K-means algorithm works. We choose the clusters and randomly place K centroids. If you see here from this scatter plot, we can understand that there are two different classes. Hence, randomly we place two centroids here. Assign each data points to the nearest centroid and create initial clusters. As you can see in picture number C, we are creating red and blue clusters based on the nearest centroid points. From the picture, you can clearly understand the position of centroids are not representing the mean value of each data points of red and blue clusters respectively. To solve this, we recalculate the centroid by taking mean of each data point in the cluster and finally moves the position of centroid to a new position. If you compare picture number C and D, you can clearly understand that the position of centroids has been moved from this position to here and from this position to here. Till now, these positions are not the central point of red and blue clusters. Hence, we have to repeat step number 2 and 3 until convergence, where convergence means after a few iterations, we get the optimal value of centroids, where centroids do not move significantly between iterations. Then we stop the iteration. And finally, if you see the picture number F, we have identified the optimal position of red and blue centroid points. Hope you have realized how K-means algorithm works internally to identify the clusters. However, in this scatter plot, it is very easy to identify that there will be two different clusters in our dataset. But if your dataset is complex, where you have a number of feature columns, it is very difficult to plot and identify the optimal value of K. To solve this, we have a method called elbow method. It is a heuristic technique to find the optimal number of clusters for a clustering algorithm of machine learning. Let's understand the process of elbow method. We apply K-means algorithm to the dataset with a range of K values. We start with K equal to 1 and apply the K-means algorithm. Next time we take K value as 2 and again apply K-means algorithm and so on. For each value of K, we evaluate some metric called sum of squared error, which is also known as inertia. Once we get inertia value for each value of K, we plot inertia versus K value to choose elbow point. In this picture, you can identify the elbow point here, where we have sum of squared error or inertia in our y-axis and different values of K in our x-axis. So, elbow method is a very effective method to find the best value of K in our K-means clustering algorithm. Note, if dataset is too complex, sometimes elbow method may not work. For such cases, we have to rely on the domain knowledge to identify the optimal value of k. Now, as you know how elbow method is helping us to find the best value of k and how k-means algorithm works internally, we are ready to write some Python code in order to implement k-means clustering algorithm. Like any other machine learning algorithms, from sklearn.cluster, we can import k-means in our code. In order to create k-means model, we need the optimal value of k, because we have to pass n underscore clusters equal to the optimal value of k. After creating the model, we can train the model. As it is unsupervised learning algorithm, we have to only pass the feature data in our fit method to train the model. We can find the centroids from a trained model with the help of cluster underscore centers. We can also evaluate inertia of a trained model with model.inertia attribute. Now let's jump to the Jupyter notebook and understand how can we implement k-means clustering algorithm with an example. We are importing pandas to use it for data preparation. Matplotlib will be to visualize data as and when needed. We are importing k-means from sklearn.cluster and importing an example dataset called iris dataset from sklearn.dataset. In this session, we will use iris dataset as an example during our coding exercise. Once we have imported all the necessary libraries, let's prepare the data to train the model. We are loading iris dataset, which has data directory and feature names, and with the help of data and feature names, we are creating our feature data frame. We know iris dataset has sepal length, sepal width, petal length and petal width, because we have used this dataset for our previous sessions as well. The problem statement is based on these features. We will be clustering the entire dataset to identify a specific species of iris flower. For simplicity, we are only considering petal length and petal width as our feature columns. Let's plot the feature columns to see the dataset. From this scatter plot, we can understand we have two different clusters here. This is cluster 1 and this is cluster 2. That means now we know the value of k. Let's create the k-means algorithm where n underscore clusters equal to 2. Model.fit underscore predict is a method which takes the feature columns as its input. It trains the model and finally predicts the cluster number, what we can see here. Few records are categorized as cluster 1 and few are categorized as cluster 0. So finally, our k-means model have created two different clusters and assigned each data points with a cluster number. Let's visualize the centroids now. Green points are the final position of centroids, and all data near to this centroid will be in a single cluster, and all other data near to this centroid will be another cluster. Hence, our k-means model, where k value is 2, has splitted the entire dataset into two different clusters. Now, we can predict the cluster number of a new test feature as well with the help of our trained k-means clustering model. But if you have gone through my previous videos, you know that iris dataset has three different clusters, or iris flowers have three different species: setosa, versicolor and virginica. That means now our model will not be able to predict a specific species of iris flower, because based on our model, it does not know that in reality the dataset has three different clusters. It has created two different clusters. Why? Because we have provided n underscore clusters value as 2 while creating the k-means clustering model. Now you have realized how critical the value of k is. If you provide wrong k value, your model will predict the cluster for a specific feature wrongly. To identify the optimal value of k, we know from our theory session that we can use elbow method. In elbow method, we take a range of k values and create multiple k-means cluster, evaluate the inertias or the sum of squared errors, plot them up to find the elbow point. Let's run this. In this plot, we have sum of squared errors in y-axis, number of different k values in x-axis. From this plot, we can easily identify the elbow point, which is 3 in this case. So the optimal value of k will be 3, not 2. Now as we know the optimal value of k, let's create a k-means clustering model when n underscore clusters equal to 3. Let's plot the centroids again. Now as you can see, our model has created 3 different clusters, and these green points are nothing but centroids for each cluster. These individual clusters are representing different species of iris flower. If we provide an unknown petal length and petal width features, our k-means model will be capable to identify the specific species or a cluster of iris flower. Let's understand the takeaways from this session. In this session, we have discussed about k-means clustering algorithm, which is the simplest unsupervised learning algorithm to solve clustering problem in machine learning. Now we know how k-means model is taking unlabeled data as its input during training of the model. We know k in k-means refers to the number of clusters. We have realized how centroids are the critical keyword in k-means algorithm. We have gone through the internals of k-means clustering algorithm. Now we know how we can easily identify the best value of k with the help of elbow method. Note that sometimes if your data set is too complex, elbow method may not work. At that time, we have to rely on the domain knowledge to find the optimal value of k. During our coding session, we have written some code to implement k-means clustering algorithm in Jupyter notebook and predicted specific cluster of iris flower or specific species of iris flower. Hope this session will add some value to your machine learning journey. Thanks a lot for watching this video.